Hello everyone, myself Joshi. Today we are going to discuss few examples of curve tracing. So let's start with the first example, that is trace the curve y square into a plus x is equal to x square into a minus x for a greater than 0. Firstly, we'll see the symmetry. Okay. So now again check the powers of x and y. Okay. So now here y square. Okay. We don't have y other and the power is 2. Now the power of x is 1 over here. Okay. Here also 1, right? Therefore we can say that the curve is symmetric about x axis because the power of y is even. Now, the curve passes through the origin as there is no constant term in the equation. Okay, so from this equation you can say that we do not have any constant. Okay, therefore this curve is passing through origin. Okay, now as the curve is passing through origin, we have to find the tangent. Okay, so for that we have to equate lowest degree term to 0. Now let's open this bracket. So this is y square a plus xy square is equal to x square a minus x cube. Okay. Now here the power is 2. Okay. Here 3, here 2 and again here 3. Okay. Now what we have to do? We have to equate the lowest degree term to 0. So lowest degree are this y square a and x square a. Okay. So we'll equate y square a, bring this over here. So minus x square a is equal to 0, right? So from this we will get y is equal to plus or minus x. Okay, so we can say that this y equal to plus or minus x are tangents at origin. Okay, now here we have two tangents, y is equal to x and y is equal to minus x. Okay, and both are real and distinct. Therefore, we can say that origin is what? Not. Okay, so y is equal to x and y is equal to minus x, right? So this is a knot, right? Now let's move to the next one, that is point of intersection. Okay, now this will find by substituting y is equal to 0. Okay, so if you will substitute y is equal to 0, this term is gone. Okay, so from here what we have, the answer of we have x square into a minus x is equal to 0. Therefore x is equal to 0 and x is equal to a. So the point of intersection are 0, 0 and a, 0. Okay, now what we'll do, we will find the tangent at this particular point a, 0, right? So for that we have to shift the origin to a, 0 by substituting x is equal to capital X plus a and y is equal to capital Y plus this 0. Okay, in the equation of curve we are doing this in order to find the tangent at particular point a, 0. Okay, so in place of x will substitute x plus a. Okay, and in place of y will substitute y plus 0 in this equation. Okay, so y square, only y square. Okay, a as it is, in place of x plus a is equal to, again in place of x plus a whole square plus this a as it is minus x minus a. Simplify this. Okay, so you will get y square into x plus 2a is equal to x plus a whole square into minus x, right? Bring this term over here. Okay, and expand this bracket, so you will get y square into x plus 2a plus x into x square plus 2a x plus a square is equal to 0. Now let's expand this. Okay, so this is y square x plus 2ay square plus x cube. Okay, plus 2ax square plus a square x. Okay, so from this the lowest degree term is a square x. Okay, so we will equate a square x to 0. Okay, so from this we will get x is equal to 0. Okay, now capital X is what? Bring this over here. So capital X is x minus a equal to 0. So from this we will get x is equal to a, which is a tangent at this particular point. Okay, now let's discuss the region of existence. So from this equation we have to make y as a subject. Okay, so bring this over here and take under root. So y will be plus or minus x under root a minus x upon a plus x. Okay, now we have to find x for which this y becomes imaginary. So there are two possibilities when a minus x is less than 0, that is x greater than a. Okay, or this a plus x less than 0, that is x less than minus a. Okay, now for this 2, okay, y becomes imaginary. So what we can say that the curve does not exist in the region minus infinite to minus a. From this we can write minus infinite to minus a, okay, and we have x greater than a, so from this we can write that a to infinite. Okay, so in this region the curve does not exist. Okay, so the curve lies in the region minus a to a. Okay, so our curve is present in this region. Now let's discuss asymptotes. Since the coefficient of highest degree term of x is constant, okay, now multiply over here. Okay, so what you will get, y square a plus x y square is equal to x square a minus x cube. Okay, so highest degree of x is 3 and its coefficient is minus 1, which is a constant, therefore there is no asymptote parallel to x-axis. Now we'll equate the coefficient of highest degree term of y to 0. Okay, so highest degree of y is what? This, here we have y square. Okay, so a plus x, right? So we'll equate a plus x to 0. So from this we will get x is equal to minus a, which is an asymptote parallel to y axis. Okay, now since the curve meets the x-axis at 2.00 and a comma 0. Okay, so curve intersect at this 0 and a comma 0. So there exists a loop, okay, which will be in the region of existence, that is 0 to a. Okay, we are considering only this part. Region of existence is from minus a to a. Okay, so a loop will be formed over here. Okay, and also y is equal to plus or minus x are the tangents at origin. Okay, this y is equal to x and y is equal to minus x, these are the tangents. Now, so after passing through the origin, the curve will extend towards the asymptotes parallel to y-axis. Okay, so this is our asymptote, x is equal to minus a, right? So this curve will extend over here, right? So in this way, our curve will form, right? Now, let's discuss one more example. Trace the curve x cube plus y cube is equal to 3axy. So first, symmetry. Now the curve is symmetric about y is equal to x, because after interchanging x and y the equation remain unchanged. Okay, so in place of x if you will write y, so this will become y cube, this will become x cube, here we have 3ayx. So equation remains same, therefore we can say that curve is symmetric about this line y is equal to x. Now, the curve passes through the origin as there is no constant term in the equation. Okay, we do not have any constant term, therefore curve passes through origin. So we will find the tangent at origin. Okay, so we'll equate the lowest degree term to 0. Okay, so lowest degree term, that is 3axy to 0. So from this we will get y is equal to 0 and x is equal to 0. Okay, so these are the two tangents at origin. Okay, now we are getting two tangents, so we'll see that they are real and distinct, therefore we can say that origin is a node. Okay, now let's discuss point of intersection. So substitute y is equal to 0 over here. So this term is gone, so x is equal to 0. So the point of intersections are 0, 0. Okay. Now the curve is symmetric about y is equal to x. So we'll substitute over here. Okay. So from this you will get 2x cube is equal to 3ax square. Bring this over here. Take out x square common. So we have x square into 2x minus 3a equal to 0. So from this you will get the answer of x as 0 and x is equal to 3a by 2. Okay. So if you will take x is equal to 0, you will get y is equal to 0. Okay. And for x is equal to 3a by 2, y will also 3a by 2. Because the curve intersect the line at 2 points, that is 0, 0 and 3a by 2 comma 3a by 2, right? Now we will find the tangent at this particular point 3a by 2 comma 3a by 2. Okay, so for that now we are using this method to find the tangent. Okay, so suppose this is a point x1 y1, so we'll use this formula y minus y1 is equal to m into x minus x1. Okay, and substitute over here. So this is y minus 3a by 2 is equal to m is dy by dx at this particular point into x minus x1, that is 3a by 2. So firstly let's find dy by dx. Okay, so for that consider the question, that is x cube plus y cube is equal to 3axy. Okay, differentiate this with respect to x, so you will get 3x square plus 3y square into dy by dx is equal to 3a into. Now apply multiplication rule over here. Okay, so x into dy by dx plus y. Alright, now we'll bring this dy by dx term together and others term together. Okay, so from this you will get the answer of dy by dx as ey minus x square upon y square minus a. Now we'll substitute this point 3a by 2 over here. Okay, so in place of x and y, just write down 3a by 2, 3a by 2. Okay, and on simplification you will get the answer of dy by dx as minus 1. So we'll substitute this over here. Okay, in this equation, so you will get y minus 3a by 2 is equal to minus 1 into x minus 3a by 2. Okay, multiply this and simplify, so you will get the answer as x plus y is equal to 3a, which is a tangent at this particular point. Okay, now let's discuss the region of existence. Now when x and y both are negative, okay, so if x and y both are negative, okay, so this left hand side of this equation will become negative. Okay, and the right hand side of this equation will become positive, right? Therefore now when x and y both are negative, it is negative in the third quadrant. Okay, so we can say that curve is undefined in the third quadrant. Now we'll discuss asymptotes. Again, so we have to equate the coefficient of highest degree term of x and y. Now, for both x and y, the coefficients are constant, so there is no asymptote parallel to x-axis and y-axis. Okay, therefore we'll find the oblique asymptote. So for that, what we'll do? So we'll substitute y is equal to mx plus c in the given question. So you will get x cube plus mx plus c whole cube is equal to 3x. In place of y, mx plus c. Okay, apply a plus b whole cube formula. Okay, so you will get this result, right? Multiply this over here, so you will get this term. Now what we have to do, we have to equate the coefficient of x cube and x square to 0, because highest power is x cube and the second highest is x square. Okay, so we'll equate this to 0. Now, so from that what we will get, now x cube is present over here, so 1 plus n cube is equal to 0. Okay, and the coefficient of x square, so you will get the coefficient of x square from this. Okay, and from this, so from here we will get 3m square c minus 3am is equal to 0. We can bring this over here. Okay, now from this 1 plus n cube is equal to 0, we will get m is equal to minus 1. Okay, we are considering only real terms. Now 3m square c minus 3am is equal to 0. So from this we can get the answer of c as a upon m. But the answer of m is minus 1. So substitute over here. So the value of c is minus a. M is minus 1, c is minus a. Will substitute over here. Okay, so you will get y is equal to minus x minus a, which is asymptote to the curve. Okay, now so what we have studied, that since no part of curve lies in third quadrant, so curve does not exist in the third quadrant, so this is blank. Now the coordinate axes are the tangents at the origin. Okay, so this x-axis and y-axis, right, these are the tangents at origin. So after passing through the origin, okay, so curve will pass through the origin and it will extend towards the asymptote x plus y plus a is equal to 0. Okay, so this is our asymptote x plus y plus a is equal to 0, right? And this is the line y is equal to x. So as we have studied that curve intersect at 0, 0 and 3a by 2, 3a by 2. Okay, and it is symmetric about the line y is equal to x. Okay, so after passing through the origin, okay, it will move in the direction of this asymptote. Okay, so in this way we can trace this curve. All right, so I hope you have understood throughout the session. Thank you for watching.